This time we are going to perform the tensile test on this given spoke. We are supposed to cut this spoke into 2 equal halves. One will go for the annealing one and other will be done directly. So we just need to cut this spoke into 2 equal halves. I'll just do that. So these are the 2 equal halves. Most probably it's 2 equal halves. One will go for the annealing and another will be tested just like this. These are my group mates. This is Harpreet Singh, this is Sukhbir Singh, and our cameraman Jaskaran Satendra.
This is our sample which is goes for annealing. For annealing we use this furnace which is preheated at 950 degrees centigrade. And for placing the sample inside we use the gloves and tongs. This is the tong and this is the glove. We have to wear the glove. And hold the sample with this tong like this. And be sure that we have fit as soon as possible. Now, for the 30 minutes we have to wait for just place the sample inside this furnace for the annealing. Annealing is a process which is used for increase the ductility and make the structure homogeneous.
My name is Harpreet Singh and I'm going to show you the tensile test of the sample of this material. So first of all, we'll measure the diameter of the sample, which is 0.074. Now my friend will put this.
Hi guys, we will now perform the tensile strength on our given sample. I'll start up the hardware. This is our United Testing Systems. So I'll just start up the hardware. We are having a new sample. We need to select the template first. It's a imperial template. So it's E8, okay. And now the scales will come up. Yeah. So now here we have scales. Scales are just coming up. Now we'll just enter up the info of the sample. Our sample info is its whole work. It has a diameter of 0.074 as my friend mentioned. It will automatically calculate the area work. Now we need to apply it and we need to jog it first. So my friend will now enter up the sample into the jog. He'll jog it and enter it. And this is how we jog it. Measure the 2-inch as the length of the extension meter is. Now then we'll mark at the boundaries of the 2-inch length. Now we'll remove the sample from the extension meter. Now we'll put the sample. First of all, just mark it properly. Okay. Now we will put the sample in the machine. Make sure the sample is in the middle of the machine. Install the extension meter. It should be right on the black marks. Boundary should be right on the black marks, right over there. And now
we'll just give a twist to the extension meter so that it do that mark. Okay, now it's done. Okay, now we'll remove it. As you can see, we have installed the extension meter in the machine. Now we'll operate the machine with the help of computer. My friend will tell you how to operate the machine.
Before software, we'll start our test. We already entered our details, apply it, test it. We already inserted our sample. Position should be 0. Force should be 0. And start the test button. Test. Just follow on the instructions and start making the graph, as you can see. Oh! As you can see, our graph line has been made. It's force versus extension. That's stress over strain. Now it says we have to remove our extensiometer. So my friend will remove the extensiometer.
Okay.
And now we'll press our enter. It says enter final gauge and press enter to return.
We'll remove the sample and measure the new length. The difference between the length will give us the extension which is caused by the machine.
These are the results we have got for the tensile test of both the samples as load versus extension curves. The blue line shows the variation of load with respect to the extension, and the pink line is drawn by taking 0.2% offset of the elastic region curve to determine the yield point and the yield strength. So now, in this picture, you can see that the left graph is for the cold work and the right one is for the heat treated. As we can clearly see that the graphs of cold work is less steeper than the heat treated. Therefore, it has a more Young's modulus and more tougher as compared to the heat treated sample. But in the case of ultimate tensile strength and the yield strength, the cold work has greater values as compared to the heat treated, whereas the percentage elongation of heat treated exceeds cold worked with 3%, which implies that the heat treated sample is more ductile than the cold work and the cold work is more brittle than the heat treated.